In this video, we'll show how to parameterize scripts and automate a series of tests. Real systems require repeated, controlled testing. Manual execution is slow and inconsistent. By automating execution, you can run many variations quickly and reliably, and capture both results and system context. This approach evolved from real-world engagements where dozens or even hundreds of tests had to be executed in a limited time window. Automation made that possible. Scripting allows you to control behavior using variables, reuse commands, and execute tests in sequence. This enables automation of setup, execution, and analysis. We'll start with variables in TrueBench, then modify a script from a prior video to make it parameter-driven, and finally, use scripting to automate a suite of tests. TrueBench includes a built-in manual. In the Advanced section, there's a topic on variables, along with scripting and programming concepts you can explore. There are predefined system variables, such as error codes, row counts, and test metadata like ID and test name. Let's look at how those variables are used. In the startup script, we defined a database connection, along with before and after run statements to maintain a test tracking table in the host DBMS. Those statements use variables to create or update rows in that table. This allows correlation with database query logs. The set command shows variables currently defined, both system variables and any user-defined values. Variables can also be used to capture input, such as prompting for a password instead of storing it in a file, and then reused in commands. You can also reference environment variables, which is useful for passwords or adapting scripts across environments. Variables can even act as aliases for frequently used commands, simplifying script definitions. Variables can also drive logic, for example, checking for errors and conditionally executing commands. Now let's apply this to text execution. We will apply variables to the workload script from a prior video. We'll modify the workload script to make key elements parameter-driven, including worker counts and pacing. Parameters are passed into scripts and referenced using positional variables. This allows the same test definition to be reused with different configurations. Now we'll create a test suite, executing a serial baseline, followed by multiple workload runs with different parameters. We'll scale the number of workers and adjust the pacing to observe how the system responds. This allows controlled variation of the same workload to be executed and compared systematically. The scripts are saved in the scripts directory with relative paths for portability. The serial test runs first, establishing a baseline, and then the first workload test with 3 workers, and the second workload test with 6 workers, and the third workload test changing the pacing. These test suites reflect real user workloads, not isolated queries. They allow you to detect changes that impact specific user groups and service levels. By separating workload behavior, issues aren't masked by unrelated activity. And because these workloads are executed consistently through test suites, you can evaluate changes over time with confidence. Next, we'll start with the assess command to understand what happened, and then use the database query logs enabled through DBMS-specific setup scripts to explain why it happened.